Hi everyone. We're going to present this asset today called PCG Graph, and PCG stands for Procedurally Generated Content. So the idea with this is to be able to generate content in Unity procedurally, something you might be more used to if you've used Unreal Engine, um, or maybe you've used GeoNodes in Blender. The concept's similar. So here, let me just delete this PCG manager. Basically, after you install the package, you can right click here and go to PCG, and you see, okay, I have a PCG manager here, and then I have some helper objects, area, Bezier curve, and two types of stacks. We're just going to start with the PCG manager. You can also assign this behavior to any object, but we'll create it from the context menu. So we'll create it here. If you already have a graph asset, you can assign it directly here. If you don't have one, you can just use the new button, hit that, it'll create it, auto-assign it. It'll create it into the assets PCG graphs folder. And from here, we can just hit the open graph editor, and this will open that graph editor here. Now, just the PCG manager, going back to it, there's a few things here. So in the settings, you see how to execute and optimize performance. Those are checked on by default, and I recommend you to keep them on. Basically, auto execute will keep refreshing the graph whenever you make a change, and then the optimized performance will make sure that it doesn't update and every single change. For example, if you're dragging an anchor, it wouldn't just keep recalculating, but it'll update once you stop dragging it, and that's just kind of save you a little bit of computing time. And there's a debug level as well, which by default is a none. You could change it to warnings and all if you need to, but we'll just keep it for none for now. Now, once you have this graph, we can try and do some basic things with it. So let's just create a plane first. We'll say this is our ground in a level, just so we have something in here. And we'll assign a material just so we can better see what's going on. Okay, so go back to our PCG manager, and again, you can create the curves and areas from here. But you can also do it from the manager itself. I can hit create and then curve from here, and this will create it in the PCG manager itself. And I can see that object here. There's a little bit of description in here explaining how to add and remove anchors and so on. So I can just start by holding shift and clicking around. And if you hold control while you're moving points, it'll snap them onto the ground. And there's a setting here which allows you to say how far off the ground you want these to snap. For the most part, you can just move these around, which is sufficient for me personally for the majority of the cases. In some instances where you need better adjustment, you could switch to the advanced mode, which will enable the handles, and you can right click any of the anchors, which will enable the handle control, and then you can drag these handles and change the angle of the Bezier curve here. Like I said, for the most part, I don't use that. Maybe to adjust some particular part of a path or something like that. But for now, I'm just going to disable that. And we could also change the tension of this. So if we needed more straight corners, we could change this here. So we have our curve. And for us to generate anything on it, there's a couple of ways to do it. We can generate items on the curve itself, or we could generate points. So let's start with the points first. And in the graph itself, you can either right click and select the add node, or you can press space and see what nodes we have available. And I can see here points, generation, and get points on a curve node. I'll add that. And in here, we see that this takes a curve, and it also has a points per meter parameter, and it outputs points. Now, for us to be able to reference a curve from the scene, we'll have to add a parameter. So we'll go here to plus curve, and now we have this parameter, and we'll call this path curve. Okay, and you can see that this is now exposed in our PCG Manager inspector, so we could drag our curve here. Okay, and for us to link it, we can drag this property. This will make it an instance of it. Okay, we can also see that whenever you select or whenever you hover this property, it'll highlight the nodes that are instances of it, and vice versa. So if I highlight this, it will highlight the node. I'm sorry, the property up here. So if I have two of these, each of these will highlight the property up in the inspector. And if I highlight this, it will highlight both of the nodes. So it's really easy to see the instances of each of these parameters. It'll also give you this number, as you see here. It says 2. We have 2 instances of this. Okay, let me delete this. Now, if I wanted to see how many points I have here generated from this curve, I can use the debug mode. I can save the curve. I'll save the graph, and I'll see here it says 718 points. And then I can see that, oh, I have these cubes generated here on the each of the points. And these cubes will also change their color based on the value of each of these points, which is a concept you might be familiar with if you've used Unreal. So each of the points can have a value from 0 to 1, and that value can be adjusted with noise and filters later. But we'll leave that for now. By default, they have a value of 1, and you'll see that they're all white. Now, if we go to see how to spawn actually items on here, let me just disable this. And there's another way you can see the debug. And okay, so if we want to use, we can use the debug points node and connect this in here. Okay, and then we save, and then we'll see, okay, we have these red spheres. Okay, and that's a little bit of a better way to, or it gives you a little bit more control on the debug and allows us to display the value. This way we have this kind of rainbowy gradient. We can change this and select the black and white, and again you will see, okay, these are all white because they have a value of 1. And we can, if we change this to have like 0.5 and reduce the density, we'll see this changes. And if we wanted to expose this parameter, we can add another float here, and we can say path density. I will say default is 0.5. We'll save. Sorry, let me save now. And then from here, I can adjust this and say, okay, this is 0.1, or I can make this really dense. We'll leave this to 0.5 right now. Okay. Now, another thing here is that because we have the curve generated on the ground, whatever we respawn, it will be on the ground. However, let's say we have this curve all the way up here, right? And for whatever reason, we have the curve here, and maybe the terrain is not flat. Maybe it has some curvature, and we want the points to be generated on top of the curvature. So we can project these points and move this node here, and we can say, we can search for project points node. Okay, and we can say, okay, plug these points in here, and the default settings should work fine. it's -1 on y, which means down, and then 1000 distance, and the layer mask includes everything. Okay, so we can hit that, and then we can plug this into the debug instead. And now we can see, okay, our points have projected down. And if we have some sort of an object, let me make this a little bit bigger. So just okay. Now, as you can see, the points are not on top of it. We'll have to save the graph again for this to refresh. If for some reason we want to, this object to automatically refresh the graph, we could select it and add a volume monitor on it, PCG volume monitor behavior, and then we can select our PCG manager. And essentially now, whenever we move this object, it will also refresh the graph and it will recalculate. So now, if we wanted to actually spawn something here, we can see we have points. So we'll have to go to game objects, generation, and generate on points. And we'll see that this takes points. It also takes an object set list. And we don't have that, so we'll create it. Game object list parameter. We'll say this is going to be our path blocks. Okay, we'll connect this here. Oh, sorry, not game objects list. This is a object set list. Okay, so we have the object set. And the difference is that the object set allows you to create multiple sets with different things in it. And I'll show you what that looks like. I have a few prepared. So if we go back to the inspector, we'll see that our path blocks has a plus sign here. Let me actually delete this property we don't need. So we have the path blocks and we have the plus, and we can add an object set. And if I go in here and I say, okay, I have the road, we'll see it immediately spawn these cubes. And we can go to the object set and see what that looks like. So the object set has multiple entries, or can have multiple entries. We just take a prefab and you can adjust the offset or rotation of that prefab, and you can also set a density. So you can have multiple prefabs here with different density, and they will spawn based on that density. So if you have, let's say, multiple grass objects with very high density and trees with low density, you'll get a lot of grass and a few trees. So for now, we'll remove this. We'll have our cubes, and let me disconnect the debug here. Another way to disconnect things is you can change the state of the nodes. So each node starts by in the enabled state. I can change this to disabled, which will disable these. And then there's also a blocker node too. So if you block node, it'll essentially block everything downflow. So it'll block the entire fork after, and it's really convenient for testing things. So I'm just going to disable this, and we have our blocks here. Now, one thing I want to make sure is that I want these to actually be oriented against the normal. So if we go back to the project, I can check this, align to normal, and bam, we now have our roadblocks oriented. Now this doesn't really looks like a road, so what we can do is we can find an update transfer node and connect it. So the objects, the list of objects that comes out of the generate we'll go into the update transform, and we can say, okay, we want the, and let's see here. So we want, this is the X, and then this is the Z and the Y. So we can essentially say, okay, we want these pretty wide, let's say 3, and let's say 0.2 high, and maybe 1 point, let's say 5 in this direction. Okay, maybe even 1.2 or something, 1.3. Okay, now this looks a little bit more like a road, and we can also randomize this a little bit. So I can look for a random vector 3 and connect it into the scale, and I can say, okay, we have the X from 3, or let's say 2.7 to 3.2. We'll leave the height the same, and then the Z will say, okay, 1.2 to 1.3, something like that. And we'll see that they're all still the same, and that's because we're not randomizing it per instance, which we can enable here. So whenever you enable this, if you have any random value plugged into any of these, it will create a new instance of the random per object. Okay, and now we can see they're all different. It's very subtle, so if I can bump this up so we can kind of see it a little bit more. Okay, so you can see now, okay, they're different, and we can also randomize the rotation. So we can clone this and plug this into rotation, and we can say we only need one for the Y. So we can say, okay, rotate from -5 +5 degrees, and this will add a little bit of rotation. It's randomized. Now, one thing that we can also do, if we have this, let's say we have a pretty sharp corner, I can insert another. So if you hold shift, you can insert another point in the curve. And let's say I can make a sharp turn. Okay. And we can see here, okay, these are, especially if they were a little bit bigger. So let's say if we increase the size, and we said, okay, these are from 1.4 to 1.7, something like that. Maybe even more. We'll see, okay, they will start to overlap a little bit. And, maybe we don't want that. So we can use simple deform, which will take game objects. And by default, it starts in Z, which I think in our case is fine because Z is the forward direction. And let's see. Okay, and I think this is fine. Let's see, let's bump the strength. And let's see, okay. Yeah, this is fine. I think our size is a little bit too big here for our case. But we can see now they started having this trapezoid shape. It might be a little bit too much of strength. Yeah. So you can adjust this and at the corners, they'll start having a little bit of a trapezoid shape, but they'll still be straight in the straight bits. All right, and that's a simple way to add a road with the curve.